Yeah, good morning, students. In this video, I will be discussing on one of the important topic in networks known as Ethernet standards. So let us see a few topics here. That is, what is an IEEE standards means, and what do you mean by Ethernet standards, its frame format, and various categorized implementations of standard Ethernet and gigabit Ethernets, and some addressing modes. Okay. In 1985, one of the society known as IEEE has started a project known as IEEE 802 projects, and there they have specified a number of specifications and functionalities for various protocols in physical and data link layer. Okay. This is a small comparison between OSA model and how the IEEE standards are made. However, I will make another video in depth on this topic. But when you see clearly here, the data link layer, the IEEE standard, when they are implementing, that data link layer has been divided into two sublayers. One is known as MAC layer and the other one is LLC. So MAC is known as media access control layer, whereas LLC is the logical link controller. So now when it comes to Ethernet, so we are mainly concentrating on LLC. So how exactly the link is controlled when the multiple nodes are going to access that link. Okay. This part I will see in the next video. So let's start from here. So as I told, there are different types of Ethernet standards like standard Ethernet as well as gigabit Ethernet. So first let us see what is standard Ethernets. So coming to characteristics, all standard Ethernets are connectionless and they are unreliable service because they will use the UDP protocol for data transmission. And coming to frame length, there are two types of frame lengths. One we call it as a minimum frame length, the other one is the maximum frame length. So if you take the frame length minimum, it will contain 64 bytes of length. Okay. And the maximum frame length will be of 1500 bytes, 18 bytes. So how much data we can transfer in this minimum frame length? It is nothing but 46 bytes. Okay, out of 64 bytes, we can transfer the data up to 46 bytes. The remaining 18 bytes are used for header length. Okay, and similarly for a frame length of 1518 bytes, we can transfer at a time 1500 bytes. Remaining 18 bytes are used for header information. So this is one of the characteristics of standard Ethernet. So where the frame length mainly depends upon the minimum or maximum, and the data transmission, that is the payload, is also depends upon what type of frame length we are using. So this is the general frame format of standard Ethernet. We have 7 bytes of preamble, so 56 bits, 7 bytes means, where we have alternate zeros and ones, and 1 byte of SFD, we call it a start frame delimiter to identify that the frame has been started. Preamble is meant to give an alert to the receiver that the frame is going to start, whereas SFD means that is the indication of that frame, means the frame which is started. So destination address and source address are nothing but MAC addresses of source and destination, and there will be 2 bytes of length field and data field which is of either I told now it is maybe of either 58 bits or 1500 bits, depending upon what type of frame length we are using. And lastly, we have 4 bytes of CRC, that is to check for errors. Normally, we are using a CRC 32 year, that is the cyclic redundancy check. So this is the simple theoretical explanation of standard Ethernet frame format. Okay. So coming to addressing, so normally what is this addressing? So every station that is connected to the Ethernet LAN will have a NIC card. We call it as a network interface card. Inside that we have what is known as MAC address. So by seeing that MAC address itself, we can identify whether that station is going to unicast or broadcast or multicast. Okay, let us see how it is possible to identify. So already I have discussed many times in the previous videos regarding this MAC address, which is of 48 bits that consists of 6 blocks. Each block will be of 2 hexadecimal number. So normally we call it as 1 byte, or we can say there are 6 bytes of data, which is nothing but 48 bits. So how to identify the addressing of that MAC address means? So as I told, there are 8 bytes. That is byte 1, byte 2, like that. 6 bytes will be there. This is what here. This is byte 1, byte 2, byte 3, byte 4, byte 5, and byte 6. 6 bytes of MAC address. Uh, just by seeing the least significant bit, means the first bit of the first byte. No need to worry about the remaining bytes. The least significant bit of first byte, if it is 0, we can directly say the data is going to unicast, means sending information to a single system. So if the least significant bit is 1, then we can say it is multicast, means the information is sending to a group of systems. Whereas if all the bits are 1, not only the first byte, for all the bytes, for all the 6 bytes, if all the bits are 1, means 48 bits are 1, we can say it is broadcasting. Okay, let us see a small example to identify this. Here you can see, for example, if I ask you identify to which address it is sending, means whether it is a unicast, multicast, or broadcast address of this MAC address. Just I told you this is the MAC address which is of 48 bits. Just to see the first byte, that is 4A. So that's true. You can see the last out of 8 bits, you can see only the 4 bits. Means A. A is nothing but 10. So using 4 bits, we can represent how like 0, 8, 9, 10. Okay, this 4 will be something like whatever it may be, but if you want, you can write that also. This is what the first byte, that is 4A. So you just see the law of least significant bit. If it is 0, then it is unicasting. So that's what here you have written. This is unicast address because A is binary in 1010, that is first bit is 0. Similarly, if you see the second MAC address, here 7. So 7 is again in binary, it is 0, 1, 1, 1. The least significant bit is 1, so it is multicasting. So if you see the last address, so all bytes are ones, means all bits of all 48 bits are 1, so it is represented as broadcasting address. So in this way, just by seeing the least significant bit of the first byte, you can identify whether it is unicast or multicast, and if all the bits are 1, then we can say it is broadcasting. So hope you understood. So we have different categories of standard Ethernets. However, I am not going in depth here. Just I will give some idea here. So these are the 4 different types of standard Ethernets. We can say 10 base 5, 10 base 2, 10 base 3, and 10 base F. 10 base 5 is nothing but 10 is nothing but the speed, at what speed the cable is transmitting. So it is a 10 Mbps speed, and the base is nothing but baseband, and 5 represents the thickness or thinness of the coaxial cable. It's the characteristic what I meant to say. So when I say 10 base 5, normally it supports bus topology and it will be having thick coaxial cable. Similarly for 10 base 2, it also supports bus topology, but it will use the thin coaxial cable. And these two will use the star topology, whereas 10 base 2 will use the untwisted pair cables, whereas 10 base F will use the fiber optic cables. Okay. And when you see the implementations, I can directly tell all these 4 Ethernet standards will use a 10 Mbps speed at the sender side to uh, convert the digital data into digital signal, and then at the receiver side to convert back from digital signal to digital data. The data will transmit at 10 Mbps, and it will use what we call that Manchester encoding technique to convert the digital data into digital signal, and a reverse process will happen at the receiver side to convert a digital signal into a digital data. So here you can see that here. Uh, Here, 10 Mbps data is coming and it is using the Manchester encoding to convert the digital data into signal, and again at the receiver side a decoder will be used to convert that digital signal into a digital data. So as I told you, everything will use the 10 Mbps speed. And here main thing you should note down is that what is the length of that cable. So the maximum length you can use is 500 meters. So if you want to extend it more, then you can use the repeaters and you can extend the cable to another 500 meters. The process can be repeated until how much length you want, you can extend. Similarly, as I told, 10 base 2, everything is same, but the only thing is instead of thick coaxial cables, we are using thin coaxial cables. And here again, the maximum cable length will be of 185 meters. If you want to extend, then again, after every 185 meters or 200 meters, you need to use the repeaters to extend the cable. And 10 base T will use the twisted pair cables, and mainly we are using this Ethernet in star topologies. And also it will also use the same Manchester encoding technique. Similarly, for 10 base F, it is used the fiber optic cables, uh, and, uh, and it will also use the Manchester encoding techniques, and everything is same. So this table will give you some idea clearly. So as I told you, 10 base 5, 10 base 2, 10 base 3, and 10 base F. So the media it is using is thick coaxial cables. 10 base 2 is the thin coaxial cables. 10 base T, two unshielded twisted pair cables, and 10 base F will use the two fiber optic cables. So what is the maximum length of the cable we can use? 10 base 5, 500 meters, 10 base 2, 185 meters, or nearly 200 meters, 10 base 2, 100 meters, and 10 base F, 2000 meters. So all these Ethernets will use the line encoding as the one of the standard encoding technique. So if you want to send the data with still higher speed, instead of 100 MB, 10 Mbps, if you want to transfer it to still higher speed like 1000 Mbps, then we have what is known as a gigabit Ethernets. Okay, we call it as gigabit standards. So here we are transmitting the data at 1000 Mbps. Okay. So here also we have four different implementations. Here also I am not going in depth, just I will give some information. So 1000 here is nothing but the speed at the cable is transmitting, and it is a baseband signal, and SX, LX, CX, and T will represent the characteristics of that particular implementation. So 1000 base SX, where SX is nothing but shortwave fiber. Okay, we are using two wide shortwave fibers for that. Similarly, for 1000 base LX, again we are using two wires, which is long wave. And 1000 base CX, where C is nothing but copper, we are using shielded twisted pair cable here. And 1000 base T, where T is nothing but twisted pair cables. We are using four untwisted pair cables here. So this is the overall representation. And all these will use the NRZ line coding technique here. At the sender side, it will encode using the NRZ line encoder, and at the receiver side, it will decode using the NRZ decoder. Means digital data is converted into digital signal at the sender side, and again at the receiver side, the digital signal is converted back into digital data. So all are transmitting with a speed of 1.25 gigabits per second. Okay, and uh, and these are all some characteristics where, as I told you, 10,000 base SX, LX, AX, and 1000 base T. What type of media it is using, how many wires it will have, and what is the maximum length of each wire, and what type, and that is going to use both the block coding as well as line coding. So no, first it will use the block coding to encode. Here you can see 8/10B block coding it will use. Then it will use the line coding technique to encode and decode. So receiver side also we are using both line coding as well as block coding. Whereas in case of standard Ethernets, we are using only the line codings. We are not using any block codings there. Here you can. So we are using only block coding techniques. Here you can see all these Manchester codings are just block coding techniques. But here we are using both the things, block coding as well as line coding. Okay. So the more information about this block coding and the line coding we will see in the upcoming classes. Okay. What is this 8/10B block coding and NRZ line codings, all those. Okay. This is what you need to understand, like what are the different standard Ethernets we have. So hope so enjoyed the video. Thanks for watching, and subscribe my YouTube channel for more videos. Bye.